Right, recording to the cloud. All right, cool. Did the lady talk and say she's recording? Normally I hear that. I didn't hear.
Yeah.
Okay, cool. All right, so this is the KMS meeting for January 4th, 2022. That's gonna take a while to say consistently, right? All right, so we were looking at the envelope encryption code inside of Kubernetes to remind ourselves of how data encryption keys were used. So Christoph, I have found that code, and the answer is that we use AES CBC. So in that case, you are correct that it is not authenticated because it does not. It's not an AES. It does not support that.
Okay, but this is not required by FIPS. I was wondering because it's one of the basics.
I don't think I understood what you just asked. Are you saying that this is not FIPS compliant because of that?
No, I was curious. Because it's such a basic recommendation from the NIST that I was surprised that we don't do it, and I was curious if there is not a hard requirement from some auditors for compliance, and this was basically my question. For example, if it's part of FIPS requirement to have this authenticated encryption.
I am unaware of any such requirement with FIPS.
Okay, cool.
As far as I know, FIPS hasn't caught up to that yet. Because if you look at FIPS for TLS, I don't think they recommend any of the ciphers that are AES. Right? They still are. I think they're roughly in the time frame of 2008-ish land, something around 2010 maybe, and AES became deployed in 2012, 2013. So they're a little behind, if I remember correctly. I'm not exactly sure of the dates, but as far as I understand, they haven't caught up to that yet. So that's my understanding there. Now, I suspect that is why this actually uses the CPC transformer. It's because they're like, it doesn't matter that much because there's no like actual attack vector that involves you tweaking data inside of etcd for a one-time use key and hoping that you manage to do something bad. Like it's a really hard attack vector, and if you can write data to etcd, you're kind of hosed at that point. It's not really anything we can do anyway. So I suspect that's why this was chosen. And I can get blamed, but I suspect this is probably like from the yeah, this seems pretty old.
Thank you for the insights. I didn't want to take hostage the meeting hostage. Maybe we should continue. As you mentioned, we don't have that much time to write a cap.
Yeah. So the thing I want. So we talked about Audit ID. So I was going to confirm to myself that Audit ID from the Kubernetes sense is what I think it is. So I'll share this piece of code too. Right, which is just right. So this is the V1 version of audit event, right? So this is the thing that's JSON serialized and sent to your audit sync, right? So got to make sure that is what we think it is, right? It comes from the place that we expect, right? So like with audit content.
This audit ID, so in our comment, at least it says it's generated for each request, right? But this is not the audit ID that the user can override as part of their REST API request.
I'm trying to remember where that is, right? So I'm looking at the code right now, so which is, like new event from request. I can share this link too. So I'm trying to make sure, like, did we just at some point just nuke that code? Like, I'm not obviously seeing it. So we are, if it's already in the context, we'll use that. Otherwise, we generate one, which is cool. But I don't remember this code doing that. So maybe this was changed.
Yeah, the context one is what the user could set, right?
Sorry, say that again, Anish?
The one in the context is probably coming from the user. So like we're seeing if the user is providing their own, if not, then we are generating a unique one.
Sure. So then let's see, where does that happen? That happens. Yeah, you're right. So this comes, yes, you're right. It happens at the very beginning of the handler chain, and it is set by the user if they arbitrarily set audit -ID as as a header, right? But that's super questionable.
Right.
Right. So that's the from our perspective, right? Like we have to come up with something better than this, right? If we wanna
Yeah, we probably don't want to use that, but that also means we cannot string it all the way from the request that originated it. So if we actually decide to not do this and generate an audit ID right before the KMS plugin is called, then that would still be there. So we will use that to pass it on to the KMS plugin, and then the KMS plugin will use it, and then the whole flow will be there. But we cannot correlate that audit ID with the user initiated action. So there'll be no correlation there.
I know, but isn't that where all the value is?
It will be of value if we can do the whole thing, like starting from the user originated request.
Right. Now, so I suppose to some degree, there's precedence for not using this ID because it's not, if I remember correctly, it's not used for like admission. Like admission webhooks, as far as I know, don't use this. I've always found that strange, though. I've found that the idea of just generating random strings and being like, yeah, that's the ID, I don't know, seems less than useful to me. But maybe I'm missing something there. I'm gonna see if I could find the admission code real fast that way. So like, so the admission request has a UID in it. And that was set in somewhere. Oh, no. ID is currently failing. And things like that. I can't figure out what you want me to do.
So what was the use case for the user passing their own audit ID as part of the request rather than uniquely generating?
I think the use case is actually not a user. I think it's like proxies and stuff, currying data through. I think that's what was the intent, is that if you chain a bunch, like, because the same code is used by like aggregated API servers and arbitrary front proxies, right? So the idea is that you want to be able to chain the whole thing. The issue is that they didn't build a trust chain to say that like the thing that is setting the ID is actually trusted to set an ID. They didn't build that concept. They just said, it's on the request. It's probably fine. Don't trust it blindly. But I was like, but if I can't trust it, then what's the point of it, right?
Right. If they set it to some really big arbitrary value, then we don't want to use that. So I think that's where the problem comes, that we can't reuse that.
Yeah, I mean, I do think there is some code in there that guards against that. But again, it's kind of silly, right? To be like, yeah, I have code that guards against it, right? Because there is a function called get audit ID truncated, which arbitrarily limits it to 64 bytes as a
Yeah, I'm trying to see where that is actually used though. Because at least for new event from request, it's only audit ID from.
Yeah, so I'm looking at get audit ID truncated, and it's like in the panic recovery, it's there in some login function. It's there with logging. I don't know what this does. With HTTP login. Good Lord, it just keeps going. Yeah, it does some.
Yeah, this is only used for logging purposes mostly.
Yeah, so that is true, right? So it does seem like
and also, like, a quick question is the audit ID even here, right? It's mostly used only for logging, right? Like, it's not actually part of storage. I mean, if it's an event, the event is stored in etcd, but other than that, it's not something that's explicitly stored. So I'm thinking even for KMS, it's the same. Even though we generate the audit ID, it's not that we're going to store it with the encrypted data, but rather it would just be part of the event, right?
I mean, in the general sense, I think you're right, but I feel like that's completely up to the KMS, right? It can choose to store it if it has some need, I guess. So in the same way that like your audit sync could decide to save some events and throw some events away, right, on its own notion of whatever is important to store, or
Right.
Might have just different retention policies for different data.
Yeah, as an event, I think it's fine. And then also like probably like audit logs, it shows up, right? But again, none of these audit IDs are persistent. Like all of these get generated for a request and then they're used by different components to log. And after that, that's it, they're gone. They're like not stored anywhere.
Yeah, so I think that property is fine. The issue is the fact that if I just arbitrarily decide to set audit ID as 1, as in all of my requests, I guarantee that you can't correlate anything of mine because they all have the same ID, and it's just going to be.
But when only bad people, just assuming that malicious people would set it to 1, you would also can track it because all the other normal users would have UIDs, I would guess, and those who have bogus data, you would see, okay, this is something is up there, and you would maybe actually look out for those audit IDs. The only issue would be when you would try to pass it as UID and you have an error, and the only thing that you enter into the audit ID would be some error message. But still then, as most of the users have proper UIDs that help you to track from the client to the database what's happening, I think it's still okay, isn't it? I mean, even if you would set every time a 1 or a 2, a 3 or 5, you would see that this is not the format that you're expecting, and everyone else comes up with a proper format. It would be a huge hint that something is going wrong.
Right, but remember the audit ID doesn't have an API schema. It's just a string, right? So today it being a UID is an implementation detail, right? There's no requirement that it stays that way. If Kubernetes decides to change that, I think that's totally fair, right? So I mean, there's still the potential of DOS, right? Because you can still set it to multiple megabytes, right? So then that'll put pressure on your backend for no good reason, really. Also, if you happen to learn audit IDs of a different user somehow, or a different component, then you can set yours to match theirs. And it makes it really hard to figure out which request was being made by who. Right? Like it's just to me really strange and difficult once you can't trust it as just a random value per request that cannot be spoofed, right? That last part is important, right? And I'm wondering if that's why like admission webhooks and stuff don't let you pick, because they want to, the point of having the UID on an admission request is to make sure that when the admission webhook responds, that it responds with its set in the response, so that the API server can understand that the admission webhook knew which request it was responding to. And also admission webhooks can be called more than once for the same request, right? So admission webhooks need to know for some amount of time if they're being recalled for this, like if they're stateful, right? For KMS, that doesn't matter as much because I don't think we ever have a flow where we would recall you. Well, no, that's not true. We might recall you on a conflict for the same request. Right. So like if we do a stale conflict and then automatically retry in the storage code, we'd call you more than once probably for the same request.
Really? I thought it's only like once. Like, I mean, when the user makes a request, that is when the KMS gets called. But after that, I don't think there's any internal retry.
No, there's a bunch of magical internal, like all of guaranteed update inside of the etcd code can invoke for the same request more than once. Right, because we maintain an in-memory cache of data, and then we use that for optimistic concurrency, right? But sometimes that leads to failure, right? So then we do a reget out of etcd and then do a re-update onto it, right? So we might do it more than once for the same request, as far as I understand, right? So yeah, so I mean, that seems important to know, right? That like all of this was happening and like it's not the user doing something funky, it's just the system behaving as it is, and still one request logically from the user's perspective. It's just multiple calls so they can't ask for that same request, but probably the first one was dropped, yes, right? Or in the sense that the encryption data was dropped.
So you're saying for admission request, rather than using the UID, that's part of the request, it's basically generated by the admission controller, and then that UID is used?
Yeah, let me find the code so that way I'm like not telling you guys a lie. But yeah, that's what I remember being the case, and I was confused. I was like, well, we have this cool audit ID, why don't we use that one? I was like, okay, fine. Maybe there's a good reason, but I mean, as far as I understand, you know, I was not involved in any of the like the design of that stuff, so I cannot say.
Yeah, I mean, if admission request is doing it, then we could do the similar one in KMS, right? Like at least start off, we can say like we would generate an audit ID, so at least we are able to correlate between the originator that basically like from the API server and then like at least KMS plugin. And then if there is ever a use case where users say they also want to string it all the way to their request, which caused this call to be made, then we can see if we can reuse this existing audit ID, which is part of the client request. And maybe even at that point, like we just have to decide that when it's actually like for KMS, maybe we won't use the user provided audit ID, but we would just replace that with a unique ID.
Would we do both? So that way you always have, you always can trust UID because you know it's always uniquely generated per request for the purpose of KMS. And we also include the audit ID with the big old thing saying that like this, the user can change this to whatever they want. So like, don't use it for guaranteed something, but like it might help you correlate something if you really want to, but it's like a best effort thing. I don't know if that like just causes more trouble than it's worth.
Did you find the UID from the audit ID?
You what?
Could you find the UID information from the audit ID?
No, that's the thing, right? So the audit ID only has, sorry, maybe I don't understand your question.
Well, because you said, should we also persist the UID?
Well, what I was saying is, should we internally for every request for KMS's purposes generate a UID for every request and have that as part of the KMS call, but then also pass in the audit ID that's already there. So basically you would have two IDs, right? One that you know is generated by the API server, guaranteed to be unique for a request, and one that you know is probably generated by the API server, but can be manipulated by the client so they choose to for good or bad reasons. It's really weird to have two UIDs on like a call, right? That's the weirdness of it. And obviously you could be goofy and like join them together or something and like, sure. But
Okay.
So this is a new UID, not the original request UID. Okay.
Yeah, so I think probably more suggesting two different fields, right? Like, so we have a new field called request ID maybe, and then that is something that's uniquely generated by the API server for every encrypt decrypt call, and then that is passed to the KMS plugin. And then there is this other audit ID field, which is reusing the audit ID, which is there today. So one is where the user can provide it as part of the request context, or it's automatically generated. But that is something that we already get when the KMS plugin is already being called. So like the audit ID is already there today. And then we could pass both of these IDs and then let the KMS plugin decide if it wants to log both of it or if it wants to pass it to the external secret store. But probably start off with request ID, which is uniquely generated for every encrypt decrypt call, so that we can correlate at least from API server to KMS plugin to secret store. That's what I understood.
Yeah, I think you got me. I think your understanding of what I was saying is correct. Something about the idea of having two UIDs in the same thing doesn't feel right. Because it basically comes down to is that we actually just want the audit ID to be trustable, and is that something we should fix? But because that might be what we should do, right? If we just fix that, then we can just use it, right? And the problem just disappears.
How do you fix that?
We have to come up with some way of saying who can and cannot set this header, right? Like there has to be some. So for example, when you're an aggregated API server, and the Kubernetes API server makes a request to you in the backend, it sets a set of headers, the front proxy headers that tell the aggregated API server who the calling authenticated user was, right? So like if Mo made a request to the API server to an aggregated API and it turns around and reverse proxies to that backend, how does that backend know that Mo made the call? Well, there's a bunch of headers set, but it doesn't blindly trust those headers. It requires an MTLS connection from the Kubernetes API server with a particular client certificate signed by a particular CA, and the CN on that client certificate has to match a particular name, right? When all of that is correctly set, then it says, cool, I'll trust those headers to tell me any identity they want. This is a Kubernetes API server talking to me, right? Otherwise, it's like, no, I don't trust those headers, right? To me, this is of equivalent importance, right?
Absolutely.
But for some reason, we were okay just saying, yeah, it's fine, everybody can set it. And that's really strange.
Maybe because it's like a file on the local host.
I mean, if you're if you're on if you're on localhost, right? Like for example, this doesn't even check like, hey, is the request from some local address or something, right? And then allow you to set. Even that would be kind of sort of okay.
That's a
right?
very low hanging, fruit.
And like then it becomes really hard to abuse in any particular way. Yeah, okay, so I finally found the code for admission as we were talking.
Is this the aggregated?
So yeah, so this is admission webhooks. When we call them, right, we generate a UID and we just stick it in there. Right, so this is completely unrelated to anything else. Right, and that's what we send through. And then later on, somewhere in here, what is it called? Might be in a different file, but there's a function called verify admission response that takes in that in-memory UID and verifies that the webhook responded correctly with that same UID. Because that's the contract. The webhook has to reply with that UID to assert to us that it's keeping track at least a little bit. Yeah. So, but in this case, we were totally happy generating a UID arbitrarily and then sending it through with no correlation to the original request.
I like your idea for the similar to aggregated APIs, like having a way to validate that it is indeed the API server making that request. If you recall, this even like the way we currently have admission webhooks is, if you recall, I had a problem with that as well. There's no way to make sure that it's only the API server can make those requests.
Yeah, because the caller to an admission webhook is unauthenticated.
Can be anybody, yeah.
Yeah. Yeah, well, I mean, the workaround is you run it as an aggregated API server, right? literally to reuse that machinery.
How hard would that be to add something like that for this?
I mean, it's so we couldn't just do it. We would have to have some way of retaining the backwards compatible behavior, right, for at least some amount of time, right? Which is today you can just set it, right? So if you today have a series of proxies in front of your API server, they can just set this value, right? And it's okay. I wish Tim was here. Oh, sorry.
No, I was gonna ask what would the change be? Like not allowing them to set the audit ID or basically validating who is setting it?
Yeah, so I mean, I'm trying to understand what the use case was. Like that, well, I'm missing some history here for like why we felt we needed this exactly, right? Because if the only case is like a front proxy that is like the other front proxy stuff we have today, we have a ton of machinery to validate those connections, right? So if that's the case, then this could use that same machinery, right? To say that, hey, in if I got a request ID from the user, that user better be that same user that is the front proxy user. Right? If that's the case, yeah, then that's totally fine. That's totally straightforward and easy because the machinery already exists. I mean, we'd have to rejigger some ordering and stuff because this runs first in the request handling, and authentication runs later technically, but that's fine. Like we could make it all work. It's totally doable. And you know, we could even make it backwards compatible by making it best effort. So what you could say is that we leave all this alone for everything else, but for KMS, the only time the audit ID would be set is if it came from a trusted source. So it would basically be empty otherwise.
Yeah.
That would be kind of annoying because then KMS would be like, well, these are untrusted requests. That's kind of strange. But at least it would know, right? It would know that, hey, someone was trying to tamper with audit ID. Not necessarily maliciously, but someone did set it on their own instead of letting the API server do it. And I guess in a sense that even that, I mean, maybe the smallest change would be that we could just enhance this code to tell, to also inside the context, make it clear when audit ID was set as a header versus not, right? And we would only pass it through when it wasn't set as a header. So that way we set it when we control it, and if not, we don't pass it to KMS. And basically all the requests to KMS that have headers, the audit ID header already set, are in one big bucket of whatever, like you can't correlate this because you can't trust the value. It's a relatively small way of doing it.
I think that's possible, but then again, like we have to explain it to users that in some scenarios, they will not be able to string the whole thing from their request all the way to the secret store. Like we have to explain the difference in behavior, which we're doing internally.
Yeah, and that's annoying. I prefer not to have to do that. I just, basically, I wish Tim was on this call so I could ask him, hey, y'all, why did you do this? Like, why did you think this was okay?
Do you think we can bring this up in the SIG Auth call tomorrow?
Yeah, I mean, there's nothing on the agenda. So if we want to sit there and have like a KMS party, we can. That's totally fine.
We could also just ask them on Slack.
Oh yeah, totally. We can. It's more of if we want to use that time to try to get a little bit more high bandwidth consensus. You know, I think that's totally fair, especially since if no one else has anything to talk about.
Yeah, let's do it. Call dibs.
Yeah, totally. We can do that. So, because if David will probably be there, so we can ask him, hey, why do admission webhooks make up their own UID and send it through? Why did we think that was totally fine for admission webhooks? Is there no desire to correlate a user's request with the webhook's behavior, like directly, right? Like Mo does create pod. What were the webhooks that handled create pod, and like, what did they do? Like, is that not important? There's also I'm honestly completely unfamiliar with what this code does because I think it was added relatively recently, but there's also this like API server tracing code, which is behind a feature flag that's alpha in 122. So it does something. It adds some tracing stuff. I don't know what we can, if that's like the new way of doing this. Maybe we've moved away from IDs and now we have this tracing thing. Because this is all the open telemetry stuff, right? That's relatively new.
This alpha and oh yeah, it uses auto.
Right, and so like if we're moving to a different way of doing tracing, then then let's not use the old way of whatever that is and let's use the other way. That way we're kind of caught up. I've never read this code before, so I'm like kind of looking at it like, what does this do? It like makes a handler with some options for the trace provider. I mean, that's cool, y'all, but like, does this have like that?
So we basically need to have the KMS plugins also implement this, right, to like visualize it all the way through.
I guess I just don't know how this code works and exactly what does it track and how does it track it. And to your question, like how would KMS be part of that trace?
Yeah, I'm looking at the blog and they have this example trace, and then in that he basically says I instrumented the example webhook with OpenTelemetry and routed traces to Jaeger.
Okay, so maybe that's the way we're supposed to do this now, I guess. So what does it mean for us to do that instrumentation? Like, what would KMS need to do either in the API or itself?
Not as part of the API, but most of this would be overloaded as part of the gRPC request context, right? So like the request ID and all those, I mean, at least for the trace span will be included in the context. And then if all the KMS plugins implement tracing with OpenTelemetry, then as a user, I would just be able to visualize that which component is taking how much time. But I think that still gives you the data on how long things are taking. But in terms of actually being able to audit, I'm not sure if tracing will give you that information that you need. Like if you open up Jaeger and then try to visualize your request actually going through, you can see where it's going and how much time it's taking. But if you want to come back later and see, like go into the logs and look at it, then you won't have that correlation. So you still need some kind of IP there.
Okay, so you could see. So I'm just not familiar with the tracing stuff. Is it when you have a trace span that has an ID, right? Though, like has some ID for that span, so
Right.
Right. So if that span is not included in the Kubernetes audit log, right, then we can't trace it because it's not in there. But to me, if this is the way forward, it should be in there, right?
Right. But I don't know if this is the way forward. Like we can check that. If this is the way forward, then what you're saying is absolutely right, because there should be some way to correlate what you're sending. So it's possible that they are actually passing the audit ID in the span itself, like rather than generating a random ID. But I think we can dig into the code and see if that's what they're doing.
Yeah, that's okay, we got like 10 minutes or so. So let's maybe take a few seconds. So like if we're gonna talk about, so yes, so Rita had already written out. So why is admission request generating its own UID? I think maybe what we want to also do instead of right, that's one question. Why? I think really this is all of the same thing, which is KMS. That, and then also we want to know why are we okay with a user setting ID on the request. And really, this is KMS observability. Right? We're basically let's see. So it is Is this a succinct way to describe what we're trying to do?
Yes.
Yeah. Should we also bring up the permission issue that anyone can basically make a request against the plugin?
Which plugin?
The KMS plugin.
So with
But
KMS,
like it doesn't have to come from the API server.
well, with KMS, it's only exposed over a Unix domain socket, right? So we cheat. We say that
Mhm.
the Unix domain socket should only be accessible on the host with host level permissions, and like SE Linux if you want to get fancy. And that's how you control access to it. But it's not supposed to be exposed on the network, right? Admission webhooks have the problem of being exposed on the network,
Mhm,
having basically non-existent.
So the fact that it's a host level thing, we assume if you have access on the host, then it doesn't matter.
Yes, that is that's the
Okay.
general consensus on that. I'm not saying that it's like the best thing, but it is what
Okay.
Or we start doing auth with gRPC.
Say what?
We start doing auth with gRPC. Is that what you're thinking?
I mean, that is certainly an option for if one wanted to harden that, right? It's not necessarily like against that to say that, yeah, I get that it's over a Unix domain socket, but I also like want further. The problem becomes then like, where does the authentication credentials come from? Right? How do you specify them to the Kubernetes API server? And then how is that any safer than the Unix domain socket? Or like if they're a file on this, like it gets really wonky. I mean, there might be ways to make it better, right? Like I'm trying to think of like, AWS instance metadata and that style of stuff. Like if you could inject something at the right place in the host, and maybe you can improve it a little bit. But I think you get like relatively mild benefits over what you get with just a regular Unix domain socket with good permissions on the socket. Do we have other things we want to talk about? So for a KEP that we're considering writing right now would just be observability improvements for KMS. So that basically comes down to these set of questions. So we're not talking. It might involve changes to the gRPC API. Those would be backwards compatible because it's just extra fields, right? And the old KMS plugin would just ignore them and do nothing with them. And we're not storing anything. And we're also really not asking the
user for any extra information.
Yeah, we're not asking the user for anything extra, so their config isn't changing. We're not really asking the KMS to do anything with it if they don't want to do anything with it. So yeah, it's pretty safe in that sense. Christoph, to your earlier question, do we want, probably not as part of this, but do we want to pursue anything related to how data encryption keys are used? And so right now, envelope encryption controls the encryption of the data encryption keys, but it does not control how they are used to do work. That is completely hard-coded into the API server as it's a one-time use key using AES CVC for the value of the etcd data, and then it's just stored.
That's a good question. So I thought initially it would be important, but you said that the probability that this could be used as an attack vector is pretty low, which most probably you're right. Yeah, and so I don't know how much we have, some of the velocity we have to achieve something. I would rely on your judgment.
So I'm trying to remember. I had started working on a preemptive like it was like a storage. Like I had made a PR to add the ability to have a different storage format for KMS, and then we never merged it because we weren't sure yet. So we didn't do that. Yeah. So
Yeah, by the way, this is also like, I think we added this to our performance improvement, like security aspect as well, the
Yeah.
GCM side.
That's a different section. Yeah.
yeah, so oh yeah, if anyone's wanting to know how KMS stores data, I did write this comment a long time ago that very clearly explains using a series of characters what is stored on disk. It's a real pain. But yeah, so the reason we didn't do this is while everyone was fine with the change, we were like, but don't we want to just change the format altogether to like a nicer structured format that we didn't just make up ourselves? So like maybe we should just do that. But it does seem like we were okay with changing this to GCM. And that can somebody remind me, GCM is an aid, right? I think it is, right? It is authenticated encryption. I'm remembering this correctly.
Yes, it is.
Yeah, that's what I thought, right? So that would give us that benefit. And because we use it for a single write, at least today, there's no replay attack or just whatever, what's the term? Too much encryption per key, whatever the attack is. I can't remember right now. I'm blanking the name. But yeah, so like we never did this then. Maybe we should. But again, like all this change did was add the ability in the API server to read such data, but not write such data, because we were prepping for one release with the idea that the next release afterwards we would switch it over. Thus, you don't have a downgrade issue, right? But if we're gonna go crazy and change the format in a much more dramatic way, then it didn't make sense to do this. Now, I'm a little regretting, right? This is like 2 years ago. If I had done this 2 years ago, at least I could use it now. Oh well.
Yeah, it's definitely an interesting topic. So the question would be if it's was pursuing it, or it really depends how many resources we will have, right? So we are all together 5 with Damien.
Yep.
Also, sorry, I think I missed it. The comment to say with the new format, this wouldn't be needed. But where is the follow-up on that?
No, sorry. The idea was that if we're gonna change the format much more dramatically and have like a completely different way, like ideally we would have a way of storing data in etcd that's encrypted that can be read with a tool that's not the Kubernetes API server itself.
No,
Right?
okay.
So you could do like, like data recovery, disaster recovery without literally having to use the Kubernetes API server.
Mm-hmm.
In that structural change, we would, if there was either a hard-coded cipher or a configurable cipher, we would make sure that this was at least the default cipher or something. Like it's the better way of doing it. But we would basically, if we were gonna make a really large structural schema change, it didn't make sense to also do this tiny little change and just go through the effort of that rollout, because it just doesn't it's a lot of work for not much gain, right? Because if it's only used for a release or two, then what was the point of doing all that rollout work? Because it still requires like a ton of tests and stuff, right? Because you gotta write the test to make sure that HA would work. But yeah, you're right that we never, I guess, followed up enough in a good way. That is true.
There's already a wishes what we could add to this AAD. So the unencrypted additional data that you can put into the AEAD in the document about KMS plugging errors and improvements. So someone already mentions what we could add there. So maybe it's a bigger topic then when we switch to ASGSM, how it would look like, right?
Yeah, I mean, I guess so. Do we have a section somewhere, right, for
in the other document, someone seems to have added such a thing, another topic, integrity validation.
Yeah, if you scroll down, I think there's option to something. Like if you scroll down a little bit in this
Option
doc.
to choose encryption protocol.
Yeah.
Yeah, so I dislike cipher configurations pretty greatly, especially in like TLS. All I find is giant foot guns for people to pick the wrong ciphers. But I do think that at the bare minimum, we should have a better schema for how we store things on disk. And if we should probably leave ourselves some space to have the ability to pick between some ciphers, I guess. Like I'm like, like I'm less sure of using ciphers like this, which don't support authentication, right? Because I don't know, it doesn't really make sense to me in like 2022 to use non-authenticated encryption modes. But FIPS is a thing, so we should probably validate that whatever we pick still like meets like FIPS requirements, just to make sure that we don't arbitrarily make it so like all government customers can't use KMS. That would be lame.
I think GSM is also allowed by FIPS.
I'm pretty sure it is. I just want to double check that because it'd be really annoying.
I think there was only some requirements for the hardware, something like this, but I'm not sure.
Yeah, there's like key size requirements and various other bits and pieces, right? And obviously, you would have to have the FIPS compiler for your API server, and your KMS would also have to be FIPS compliant, et cetera, et cetera. But like it's all technically doable today, right? And I realize we're like 3 minutes over time and actually late for my next meeting, so we probably need to drop. But yeah, let's just focus on the observability stuff tomorrow, and let's see if we can nail down something. I think that would at least some of it should be tenable within the next release, right? So let's just focus on that.
Sounds good.
Sure. Bye, Al. Thanks for your time.
Thank you.
Bye.